Okay, this is a video on our lesson for solving rational equations. We want to start by factoring denominators if we can, and looking at these first two denominators, neither one can be factored. So we're just going to think about them as a group with addition or subtraction, groups terms together. Here's how we know that they can't be factored. If you have your factoring flowchart, you start by trying a GCF first, and they don't have a GCF. And then you look at two terms. The only method we're working with for two terms is difference of squares. That means it has to be a subtraction, which neither of them are. And then we also need to have perfect squares for both terms, and neither of them do. And so they don't factor, and that's okay. Sometimes that will happen. So step one is not applicable. We can't do that. So then we want to create a common denominator for them both, at least common multiple. And how you want to do that is you look at the parts of the denominator, and your common one has to have each of the individual parts in it. So this is my first individual part, a plus 5. This is my other individual part. So my common denominator needs to represent both of them. So it's going to be a plus 5 times a plus 1. And then the next step is to rewrite the fractions so that they match the common denominator. So for this one on the left with the a plus 5, it's missing a plus 1 in its denominator, so I need to multiply that. And whatever I do to the bottom, I also do to the top. And then the right side has the a plus 1, and it's missing the a plus 5. So multiply by top and bottom there. Then the next thing we can do is cancel the denominators. Just get rid of them. What's happening here is if I were to multiply both sides of the equation by the common denominator, which I can do because it's an equation. Remember, if you do something to one side, you can do it to the other, and you've preserved the inequality, or sorry, the equality of the situation. We're just going to assume that we've done that and that the denominators have canceled. We're just going to go straight to the canceling part right here, and then write the remaining numerators down. So a plus 1 times a equals 3 times a plus 5. And then one thing I wanted y'all to add, we talked about this in class, add right here, do distributive properties. So I'm going to do those here. Distribute this a, that gives me a squared plus a. On the right side, distribute gives me 3a plus 15. And now our last step is to solve the remaining equation. If it's a regular equation, we can use our regular algebra. This one has a quadratic, a squared term, so I know I'm probably going to have to factor at some point. So if I need to factor, my first step is to set the equation equal to 0. So I'm going to keep this positive a squared on the left and move the stuff from the right over to here. So I do that by doing the opposite of both, which is in this case subtraction for both of them. So on the right, everything cancels, leaving me 0. On the left, I'm going to combine like terms, which is only the a's right here. So a squared combines with nothing. Negative 3a, positive 1a is negative 2a, and then minus the 15. So now we need to factor. I'm on the factoring step. I'm going to use my factoring flowchart if I still need that help. It's a cross problem, and it's our shortcut cross because the a value is 1. So shortcut means what multiplies to AC and adds to B, what A, and right here, I don't mean this A variable, I mean the coefficient, which is 1, C is negative 15, B is negative 2, two numbers that multiply to negative 15 and add to negative 2 are negative 5 and 3. We don't need to do this long method where we split the middle term, do our grouping, and then factor. That's for when the a value is not 1, the first coefficient. Our a value is 1. So we're going to go straight, we're going to take these two numbers and just write our factored form. A minus 5 times a plus 3. And then the last step, set those factors equal to 0 and solve. So we break it up, we say a minus 5 equals 0, or maybe a plus 3 equals 0, right? Because if two things are, this group times this group is 0. Well, the only way you can get 0 is if one or both is 0. So we break them up individually and make them equal to 0. And then we solve by adding 5 to both sides here and subtracting 3 to both sides here. And so that's my final answer. All right, I'm going to go through the next two a little bit more quickly without all the additional explanation of why we're doing what we're doing. So in this one, we can do step 1. I can factor this third denominator right here. That is shortcut cross. What multiplies to 10 and adds to 7, and that is 5 and 2. So I'm just going to rewrite this as x plus 5 and x plus 2. So now I look at my three denominators and try to come up with one that represents all of those. And this x plus 5, x plus 2 that this one already has, that's going to be the one that works for me. Because it already has an x plus 2 for this first fraction, and it already has an x plus 5 for this second one. So now I have my common denominator, and I'm going to do step 3, rewrite the fractions. So this first one has an x plus 2. Now it needs an x plus 5. This one has an x plus 5. Now it needs an x plus 2. And then this one on the right side of the equation doesn't need to be rewritten at all. So now we cancel the denominators. And this leaves me x plus 5 times 4. I'm going to put the x plus 5 in parentheses because the whole group is being multiplied by 4. Plus 3 times the whole group of x plus 2. So I put parentheses there. Equals 5. We do our distributive properties here. So distribute, 4x plus 20, distribute, plus 3x plus 6 equals 5. Combining like terms gives me 7x plus 26 equals 5. Now, since this doesn't have a quadratic, we don't need to factor. We can solve this in the traditional way we solve linear equations. So we would subtract 26, and that would give me 7x equals negative 21, and then divide by 7, and x equals negative 3. And then for this last one, what's different is that we have this term with no denominator, but we still need to get a common denominator. So when we see no denominator, we know that it's an implied 1. Now we can't factor any of these. So we are going to go straight to our common denominator. These two already match. They're a d plus 3. So we need to make this 1 into a d plus 3. So our common denominator is going to be that, d plus 3. Now, I don't need to change this first fraction. It's good. But for the d over 1, I'm just going to multiply by d plus 3, top and bottom. And I don't have to change this last one at all. So now I get rid of the denominators, and I'm left with 4d plus d times all of d plus 3, so I need parentheses, equals 8. Do distributive properties. So distribute, so 4d plus d squared plus 3d equals 8. So now that I have a combination of squared terms and linear terms, I'm probably going to have to factor. So I need to get this set equal to 0. So I have all these terms, including my squared term on the left. I want to keep them on the left, which means I need to get this 8 and move it over there too. So minus 8 to both sides. And I'm going to combine like terms here as well. So I'm going to write this in standard form with the biggest exponent first. So d squared first, 4d and 3d is 7d, and then minus 8 doesn't combine with anything. So now I have a trinomial. We're going to do our shortcut method. What multiplies to AC and adds to B? The A value is 1. So 1 times negative 8, B is 7. And then 8 and negative 1 will work for me here. So straight to factored form, d plus 8 times d minus 1 equals 0. Set them individually equal to 0. And solve by doing the opposite to both sides. So subtracting 8 here gives me negative 8, and adding 1 here gives me 1. And there we go.